Ladies and gentlemen, right now across massive automated parking fields lit by endless white floodlights, billions of dollars worth of brand new 2026 vehicles are sitting completely untouched, silent machines built by some of the most advanced robotic factories on Earth. These cars were supposed to dominate the future. Instead, they are rotting on lots while AI-powered assembly lines continue producing more every minute. Hidden behind those factory walls are machine systems so advanced they can build entire vehicles in seconds, predict human behavior with artificial intelligence, and operate almost without human hands. But something went terribly wrong. Tonight you are about to see the shocking reality of how the world's smartest machines created a crisis nobody expected. And in 2026, something unexpected is happening across massive dealership networks and automated vehicle distribution hubs. Rows of brand new machines polished to perfection, loaded with digital intelligence and engineered with futuristic precision, are sitting completely untouched. Millions of dollars in advanced manufacturing systems continue operating at full speed. Robotic assembly lines continue moving with machine-level accuracy, yet some of the newest vehicles entering the market are silently failing before they even leave the lot. And at first glance, these cars look like products from the future. Massive touch interfaces glow across ultra-clean dashboards. AI-assisted driving systems calculate traffic patterns in milliseconds. Sensors scan every direction with military-grade precision. Software updates arrive wirelessly overnight like smartphones evolving while parked. Every panel is sculpted for aerodynamics, every surface designed by computational systems focused on efficiency, speed, and automation. But despite all this technology, consumers are walking away. And the reason is far deeper than design. And a new era of buyers is emerging, and they no longer think like traditional drivers. In the age of intelligent machines, people expect seamless ecosystems, instant connectivity, adaptive software, autonomous capability, and energy efficiency that feels almost invisible. They want machines that behave like living systems. If a vehicle feels outdated for even a second, the market reacts immediately. And some of these brand new 2026 cars entered production with enormous expectations. Factories expanded, supply chains accelerated, AI-powered forecasting systems predicted huge demand, warehouses prepared for non-stop movement, autonomous transport trucks delivered inventory across continents with perfect timing. Yet now thousands of units remain parked under massive LED floodlights, unmoving, waiting for buyers who never arrived. And one major issue is speed of innovation. The automotive industry is no longer evolving in years. It is evolving in months. A car released today can feel technologically ancient before the next season begins. Companies racing to dominate the future are deploying smarter batteries, faster charging systems, cleaner software architecture, and self-learning automation at a pace traditional manufacturers cannot match. And as a result, some vehicles arriving in 2026 already feel behind the timeline. Consumers instantly notice slow operating systems, outdated driver interfaces, inefficient energy management, or limited autonomous functionality. In a world controlled by algorithms and intelligent ecosystems, hesitation equals failure. And another hidden problem is overproduction. And advanced robotic factories are now capable of manufacturing vehicles at astonishing scale. Automated welding systems never sleep. AI-controlled paint facilities operate with microscopic precision. Logistics algorithms optimize every movement across the supply chain. But these systems are so efficient that manufacturers sometimes produce more inventory than real demand can absorb. And the result looks almost surreal. And gigantic parking lots filled with untouched vehicles stretching to the horizon like futuristic storage fields. Drone footage reveals endless rows of silent machines reflecting sunlight across empty asphalt. Cars designed to represent the future instead become frozen inventory waiting for a market that has already shifted direction. And some vehicles also failed because they misunderstood what modern consumers truly value. Luxury alone is no longer enough. Power alone is no longer enough. Buyers now prioritize intelligence, automation, adaptability, and ecosystem integration. They want vehicles that connect with homes, devices, navigation systems, energy grids, and digital lifestyles without friction. And a machine that cannot integrate smoothly into this new technological ecosystem feels disconnected no matter how advanced it appears externally. And pricing is another critical factor. Many 2026 vehicles launched with premium pricing structures based on old market assumptions. But the rise of software-defined transportation changed everything. Buyers are now comparing vehicles the same way they compare technology products. They expect constant improvements, digital upgrades, AI enhancement, and long-term software support. If a vehicle costs too much while offering limited future adaptability, buyers hesitate instantly. And then comes the psychological shift. And the modern market is obsessed with momentum. People want what feels new, disruptive, fast, and revolutionary. The moment a car becomes associated with stagnation, inventory begins slowing down. Social media algorithms amplify perception at massive scale. One viral discussion about poor software, charging limitations, or outdated design can influence millions within hours. In this environment, public opinion moves faster than manufacturing systems can react. And even more fascinating is how electric mobility transformed expectations entirely. Silent acceleration, instant torque, autonomous features, AI-assisted navigation, predictive maintenance systems, and intelligent battery management have changed what drivers expect from machines. Vehicles that fail to deliver these experiences now feel trapped between generations. Not old enough to be classic, not advanced enough to feel futuristic. And while these unwanted 2026 cars remain parked across dealership networks, the factories continue evolving. Engineers continue training neural networks. Battery technology continues accelerating. Robotics become more efficient every month. The next generation of intelligent mobility systems is already approaching at full speed, preparing to replace machines that only recently arrived. And that is the brutal reality of the modern automotive future. In an era driven by software automation and machine intelligence, standing still for even a moment can leave an entire fleet rotting in silence under the lights of tomorrow. And at the center of this transformation is something far more powerful than manufacturing alone. Hidden behind massive industrial walls are fully synchronized production ecosystems operating with almost no human delay. Robotic arms move with sub-millimeter precision, assembling entire vehicle frames faster than traditional factories once installed a single engine component. Laser-guided systems scan every surface in real time. AI-driven quality control cameras analyze thousands of microscopic details every second, searching for imperfections invisible to the human eye. And yet, despite this incredible technological power, many of these vehicles continue stacking up in silence. And the contradiction is almost unbelievable. Humanity has created factories capable of producing some of the most advanced transportation machines ever built, but the market itself is evolving faster than the machines being delivered. Consumers are no longer impressed by technology alone. They expect evolution built directly into the machine itself. They want vehicles capable of learning, adapting, updating, and improving continuously through software intelligence. And inside some of the newest 2026 vehicles, entire operating systems now control acceleration, mapping, battery optimization, climate behavior, navigation prediction, and autonomous safety calculations simultaneously. Artificial intelligence constantly gathers driving data, analyzing patterns to improve efficiency with every mile traveled. Sensors communicate with onboard processors millions of times per minute, creating a digital nervous system capable of reacting faster than human reflexes. But for several brands, the systems arrived incomplete. And some vehicles launched with futuristic hardware but outdated software architecture underneath. Others introduced complex automation systems that consumers found unreliable or unnecessarily complicated. In an age where simplicity and intelligence must operate together seamlessly, even advanced technology can become a weakness if it creates friction instead of flow. And that is why certain cars in 2026 now sit motionless across gigantic storage facilities, while competitors continue dominating attention with cleaner ecosystems and faster innovation cycles. And what makes this even more fascinating is how the production systems themselves continue accelerating regardless of demand. Factories powered by machine learning algorithms constantly optimize assembly efficiency. Automated supply chains calculate inventory movement before orders are even confirmed. Smart logistics systems redirect shipments across continents within seconds. Warehouses run on predictive analytics capable of forecasting regional demand patterns weeks in advance. And yet sometimes the algorithms fail to predict one thing: human perception. And the modern automotive market is driven as much by digital psychology as by engineering. The moment a vehicle is perceived as outdated, overpriced, or technologically behind, the entire momentum collapses with shocking speed. Social platforms amplify criticism instantly. Viral clips exposing software lag charging issues or confusing interfaces spread across millions of screens within hours. Suddenly, a machine engineered through years of development begins losing relevance in real time. And meanwhile, the factories continue producing. And autonomous transport carriers deliver fresh inventory every night. Fully robotic loading systems organize vehicles with mathematical precision. Drone surveillance monitors storage lots from above, tracking inventory movement down to individual parking positions. Artificial intelligence calculates weather exposure, battery maintenance cycles, and logistics rotation automatically. Everything functions like a living machine ecosystem designed for infinite scale. But the vehicles remain parked. And some analysts believe the problem goes even deeper. The automotive industry may now be experiencing a collision between hardware speed and software speed. Traditional vehicle manufacturing still requires massive physical infrastructure, industrial tooling, robotics calibration, and global supply coordination. But software evolves exponentially faster. Consumer expectations are now shaped by smartphones, AI assistants, and cloud-based ecosystems that improve constantly. And this creates a dangerous imbalance. And a vehicle designed 3 years ago may already feel technologically old before mass production even begins. By the time it reaches dealerships, newer battery chemistry, faster processors, smarter autonomous systems, and more advanced neural network driving models may already exist elsewhere in the market. And that is why many buyers hesitate. And they are no longer simply purchasing transportation. They are investing into long-term technological ecosystems. They want machines that remain digitally alive for years, capable of evolving through over-the-air intelligence updates and AI-driven optimization. If a vehicle feels static, consumers immediately sense the risk of technological aging. And at the same time, another massive shift is unfolding behind the scenes. Many companies pushed aggressively toward all-digital interiors, replacing physical controls with centralized software interfaces. Massive displays now dominate cabins like command centers inside futuristic aircraft. Touch-sensitive surfaces control nearly everything. Voice command AI systems manage navigation, temperature, lighting, and driving modes simultaneously. But not every consumer embraced the transition. And some drivers discovered that hyper-digitized environments can feel overwhelming instead of intuitive. Others experienced frustration when basic functions required navigating layers of software menus. In the race toward futuristic minimalism, certain manufacturers accidentally removed the sense of instant human control people still subconsciously expect. And this tension between machine automation and human instinct is becoming one of the most important battles shaping the future of transportation. And while these challenges grow, the industrial systems behind vehicle production continue becoming more advanced than ever before. Gigafactories now operate almost like automated cities. Thousands of robots move in coordinated patterns beneath endless LED lighting systems. AI-controlled energy grids regulate electricity usage dynamically across entire production zones. Battery cells flow through conveyor systems with machine-perfect synchronization. Every second is measured, optimized, and analyzed. And the scale is difficult to comprehend. And some production facilities now manufacture enough vehicles in days to equal what older factories once produced in months. Massive casting machines shape vehicle structures using revolutionary manufacturing methods designed to reduce complexity and maximize speed. Advanced materials engineered through computational simulations create lighter frames, stronger crash protection, and improved aerodynamic efficiency simultaneously. And still, some of the finished products emerge into a market that no longer waits. And because in 2026, the automotive future is no longer defined only by horsepower, luxury, or design. It is defined by intelligence, velocity, the ability of a machine to evolve faster than expectations themselves, the ability of software ecosystems to remain alive, adaptive, predictive, and endlessly scalable, inside an industry where the next breakthrough is always approaching from somewhere beyond the horizon. And now imagine the scale of what is happening behind those silent parking lots. Beyond the public roads and glowing dealership showrooms, exist industrial environments, so massive they resemble futuristic machine civilizations rather than factories. Endless streams of robotic systems move beneath towering ceilings filled with synchronized lighting grids. Conveyor platforms glide continuously across miles of automated pathways, while artificial intelligence coordinates every movement with mathematical precision. And inside these facilities, raw aluminum enters one side of the system, and fully assembled intelligent vehicles emerge from the other at astonishing speed. Giant casting machines operate like mechanical volcanoes, injecting molten metal into precision-engineered molds under extreme pressure. Sparks explode across sealed production chambers while robotic extraction arms lift newly formed vehicle structures into the air within seconds. Entire chassis platforms are created faster than traditional factories, once stamped individual components. And the sound is relentless. And hydraulic systems pulse like the heartbeat of a gigantic machine organism. Laser scanners sweep across metallic surfaces in synchronized motion. Autonomous transport carriers navigate factory floors without drivers, silently delivering components to robotic assembly stations operating 24 hours a day. Massive articulated robots rotate with impossible smoothness, welding thousands of connection points with microscopic accuracy, while AI monitoring systems inspect every weld in real time. And nothing stops moving. And every second inside these facilities represents millions of calculations. Sensors embedded throughout the production network collect oceans of data continuously. Temperature variations, vibration patterns, battery cell alignment, paint thickness, energy efficiency, robotic movement speed, and airflow conditions are all analyzed instantly through machine learning systems designed to eliminate delays before they even happen. And the factories are no longer just manufacturing plants. They are self-optimizing intelligence networks. And entire sections operate in near darkness because robots no longer require traditional lighting. Automated systems communicate directly with each other through invisible digital coordination. One robotic station predicts the timing of another before movement even begins. AI forecasting engines calculate supply chain demand while vehicles are still being assembled. Software models simulate production flow across entire continents in real time. And still outside these gigantic industrial ecosystems, rows of completed vehicles remain untouched. And under endless fields of floodlights, thousands of cars sit motionless like frozen machines waiting for activation. Their glossy surfaces reflect neon lighting, while autonomous software sleeps silently beneath the body panels. Some still carry protective factory coverings. Others remain plugged into automated battery maintenance systems, designed to preserve performance during long-term storage. And it creates a strange image of the future. Machines built for speed trapped in stillness. And what makes the situation even more intense is how advanced these vehicles truly are. Many contain computing power that rivals high-performance data systems from only a few years ago. Their processors constantly monitor traction stability, environmental awareness, thermal regulation, and energy distribution simultaneously. Radar modules scan surrounding spaces in milliseconds. Camera arrays feed live information into neural network processors trained on millions of driving scenarios. And these cars can recognize road markings, calculate collision risks, monitor driver behavior, optimize battery temperatures, and update internal software wirelessly from cloud-based systems located thousands of miles away. And yet consumers continue hesitating. And because modern buyers are now hyper-aware of technological momentum, they study charging speed, software responsiveness, autonomous capability, ecosystem compatibility, and update frequency with the same intensity once reserved for engine performance. The machine itself is no longer enough. The digital intelligence inside the machine has become the real product. And this is where many 2026 vehicles encountered a brutal reality. And some manufacturers engineered extraordinary hardware, while underestimating the importance of seamless software integration. Others rush futuristic concepts into production before their operating systems reach full maturity. Tiny delays in screen response, inconsistent automation behavior, or confusing digital controls suddenly became major weaknesses in a market obsessed with frictionless technology. And the public noticed immediately. And in the age of viral algorithms and instant online reaction, perception spreads faster than manufacturing cycles can respond. One negative demonstration filmed inside a vehicle can circulate globally before the next production shift even begins. Consumers watching through glowing smartphone screens instantly form opinions about machines they have never physically touched. And meanwhile, the factories continue operating at maximum scale. And battery production zones stretch across enormous automated facilities where thousands of cells move through robotic inspection tunnels every hour. Precision lasers measure microscopic defects invisible to human vision. AI-controlled cooling systems maintain exact thermal conditions across entire assembly sectors. Autonomous forklifts glide silently between storage towers stacked with advanced components reaching toward the ceiling like metallic skyscrapers. And everything moves with impossible coordination. And even the paint systems feel futuristic. Robotic sprayers rotate around vehicle bodies with fluid machine choreography, applying perfectly calculated layers of color under controlled atmospheric conditions. Drying chambers use intelligent airflow management to optimize curing speed, while reducing microscopic contamination. Cameras scan every reflection on every surface, searching for imperfections smaller than dust particles. And the vehicles emerge looking almost unreal. And sharp LED lighting signatures cut through darkness with surgical intensity. Glass roofs stretch seamlessly across aerodynamic structures. Flush-mounted sensors hide beneath polished surfaces. Digital cockpits illuminate instantly like command centers inside autonomous spacecraft. Ambient software interfaces react to touch, voice, and environmental conditions simultaneously. But despite all this sophistication, many vehicles are struggling because the market itself has transformed into a high-speed technological battlefield, where only the most adaptive systems survive. And competition now evolves faster than industrial timelines. And a company may spend years engineering a new platform, only to discover that battery breakthroughs, charging infrastructure expansion, or AI driving improvements have already shifted consumer expectations by launch day. What once felt revolutionary can suddenly appear delayed. Machines designed for tomorrow risk arriving in a world already demanding the next generation beyond them. And this creates enormous pressure inside the industry. And factories capable of producing hundreds of thousands of vehicles now depend entirely on maintaining technological relevance at all times. Even a brief slowdown in consumer excitement can leave gigantic inventories accumulating at terrifying speed. Parking lots overflow. Distribution centers expand. Automated logistics systems reroute unsold units across regions, searching for demand patterns that continue shifting unpredictably. And through it all, the machines continue waiting beneath the lights, fully charged, fully assembled, loaded with artificial intelligence, surrounded by the most advanced manufacturing systems humanity has ever created, while somewhere beyond those endless rows of silent vehicles, engineers are already designing the next wave of machines intended to replace them. And somewhere inside those enormous industrial complexes, beyond restricted corridors and sealed automation chambers, the next stage of vehicle production is already unfolding at a pace almost impossible to comprehend. Deep inside these facilities, machines are now building machines. Autonomous calibration robots inspect other robotic systems with laser precision, adjusting movement tolerances smaller than the width of a human hair. Every motion is timed, every vibration measured, every microscopic delay corrected instantly through predictive AI systems, monitoring the entire ecosystem like a digital brain overseeing a mechanical civilization. And the environment itself feels engineered for the future. And cold white lighting stretches endlessly across metallic production halls. Massive ventilation systems move air with controlled precision to maintain exact atmospheric conditions around sensitive electronics and battery modules. Transparent safety barriers separate synchronized robotic zones where sparks flash continuously like artificial lightning storms trapped inside glass chambers. The floor vibrates softly beneath the movement of automated transport platforms carrying unfinished vehicle frames deeper into the network. And nothing inside the factory feels random. And even the silence between mechanical movements feels calculated. And high above the assembly lines, suspended data screens display live production metrics flowing endlessly across digital dashboards. Thousands of sensors stream real-time information into centralized AI systems capable of detecting inefficiencies before human operators would even recognize them. If a robotic arm slows by a fraction of a second, the system reacts instantly. If a battery cell temperature rises slightly outside the optimal threshold, cooling systems adjust automatically before production flow is affected. And this level of precision is no longer considered extraordinary. It has become necessary. And because the modern automotive battlefield is now driven by production velocity as much as engineering quality, companies are racing not only to build better machines but to build them faster, smarter, and at greater scale than ever before. Entire industrial strategies now revolve around reducing manufacturing complexity by seconds, eliminating unnecessary components, and compressing assembly timelines without sacrificing performance. And some factories now complete major structural assembly processes in under 2 minutes. and gigantic robotic presses slam downward with earth-shaking force, shaping massive body sections instantly. Multi-axis welding systems rotate around vehicle frames like mechanical swarms, firing synchronized bursts of blue-white energy across connection points with impossible speed. Autonomous inspection drones hover silently above production lanes, scanning every surface through machine vision systems trained to recognize flaws invisible to traditional cameras. And through all of this movement, the atmosphere remains strangely calm. And there are no frantic motions. No wasted energy. The machines operate with cold confidence, as if the entire factory already knows what will happen hours before the process begins. Conveyor systems glide without interruption. AI-directed logistics routes change dynamically in real time. Storage towers automatically reorganize components based on predictive assembly forecasts generated by neural network demand models. And outside the factories, however, another reality waits. And massive distribution centers continue expanding across industrial zones near highways, ports, and rail systems. Satellite images reveal gigantic fields filled with untouched vehicles parked in perfectly aligned rows stretching beyond visibility. During the night, floodlights illuminate thousands of reflective surfaces, simultaneously creating the appearance of an endless futuristic grid, glowing beneath the darkness. And some of these vehicles have never even been test-driven by consumers. And their batteries remain fully charged through automated maintenance systems cycling power continuously. Their software updates wirelessly every few weeks through cloud-connected infrastructure. Diagnostic AI quietly monitors system health, while the vehicles remain parked motionless, waiting for movement that never comes. And this is where the contradiction becomes almost cinematic. And humanity has created machines intelligent enough to monitor themselves, factories advanced enough to operate like autonomous ecosystems, and logistics networks capable of moving inventory across continents with algorithmic precision. Yet consumer behavior remains one of the few variables impossible to fully automate. And in that uncertainty terrifies the industry. And because every unsold vehicle represents far more than in used inventory, it represents millions of synchronized calculations, supply chain decisions, robotic labor hours, energy consumption models, software engineering cycles, battery resource allocation, and predictive market forecasts, all colliding with the unpredictable speed of public perception. And inside research facilities connected to these factories, engineers are already attempting to solve the problem through even more advanced systems. Artificial intelligence models analyze social behavior patterns, digital engagement trends, infrastructure expansion, charging network growth, economic fluctuations, and regional purchasing psychology simultaneously. Algorithms attempt to predict not only what consumers want now, but what they will desire months into the future. But the future keeps accelerating. And every breakthrough instantly raises expectations for the next one. Faster charging creates demand for even faster charging. Smarter autonomous systems make older automation feel primitive overnight. More efficient batteries redefine what consumers consider acceptable range. The industry exists inside a permanent state of technological escalation where stability itself almost disappears. And this relentless acceleration affects the machines directly. And vehicles once considered revolutionary only a year earlier suddenly begin looking outdated under showroom lights beside newer models equipped with cleaner interfaces, sharper AI systems, and more integrated digital ecosystems. Consumers entering dealerships no longer ask traditional questions first. Many immediately test software responsiveness, display fluidity, voice recognition accuracy, autonomous driving confidence, and charging ecosystem compatibility, before even considering performance numbers. And the vehicle has transformed into a rolling computational environment. And some interiors now resemble minimalist technology laboratories more than traditional cabins. Curved displays glow softly across seamless dashboards, while hidden processors continuously calculate environmental data in the background. Ambient lighting adapts dynamically to speed, weather, and driving conditions. Intelligent climate systems learn user behavior patterns automatically. Predictive navigation algorithms monitor traffic systems miles ahead, while optimizing energy efficiency in real time. And still, for certain vehicles, something feels missing. And not because the machines lack capability, but because the industry itself has entered a phase where innovation moves faster than emotional connection. Some manufacturers became so focused on technological sophistication that they underestimated how quickly consumers adapt to advanced systems. Features once considered unbelievable now become expected almost immediately. And the consequence is brutal. And factories continue evolving into hyper-efficient machine ecosystems, while product life cycles shrink rapidly under constant technological pressure. A vehicle can emerge from one of the most advanced production environments on Earth and still face irrelevance within months if public excitement shifts elsewhere. And in somewhere tonight beneath the cold glow of industrial floodlights, thousands of perfectly engineered machines remain parked in total silence, while automated factories on the horizon continue producing more with unstoppable precision.